Hello everybody, hello dear student. Today I will discuss with you about wheat diseases. Let's start from reference. You can get any information about from this reference, some references from here and some from abroad. And you can find all these references from our main library, also from our department, plant protection department. And you can also, if you want to get more information, and you can apply for internet, and you can get more information also from internet. At first, I would like to give some information about yield losses. At least approximately 10 to 30% of global food production loses by diseases. And IGRIS estimates that the annual losses by diseases cost approximately more than 2,220 US dollar. And what's the important disease of wheat? I made these groups for wheat diseases. At first is rust diseases, which is caused by fungi Puccinia. And you can see in here different kinds of rust diseases. At first is stem or black rust, which is we call in Latin name is Puccinia graminis, and here the second is brown rust or leaf rust, which is also called this Latin name is Puccinia tritia, and here is last one, yellow or sometimes we call strip rust, Puccinia striformis tritia. Another group is in here, we can see smuts of wheat, and you can see in here different kind of smuts of wheat. At first is buns caused by the moss fungi Tilletka, and other is healed bun, common bun, or skin smut, covered smut, which is both of them very closely related fungi. And here, as you can see, Lozes smut, Uslazgo unuda, and other smuts. I add to here also another disease name, powder mildew, and I will show you more information about these diseases. What's a Puccinia? Let me briefly explain you classification of Puccinia. The kingdom is Mycota, division is Amycota, and subdivision Basmycota, and classes Telomycete, Uridinalis, and family is Pucciniaceae. The Puccinia is a very large genus with about more than 1,800 species, particularly distributed in the all parts of the world, also in Azerbaijan. Puccinia is an obligate parasite. It is a heterozygous parasite. The life cycle on the wheat and also barberries, which is in here. In this point, wheat is a primary host, and barberry is a secondary, or sometimes we call this alternate hosts. So here is the life cycle of Puccinia. You can see in here two sites on our pictures, which is include here 5 stages of life cycle of Puccinia. And here, as you can see, first is spermagonia and acium, which is both these stages. We can see in here sexual stages of the barberries and Puccinia. You can see in here, and other is wheat. Uridina, Telia, and Basispores, which is these stages include the asexual stage of the wheats. And you can see in here Uridia, Telia, and Basispores. So you can see in here the Puccinia infection and symptoms. Here, as you can see, downside of leaf, and here is upper side of leaf. And you can see in here clearly the yellow color. So, Puccinia polymorphic fungi, what's a polymorphism? The polymorphism is a various types of the spores produced during the life cycle according to the host life cycle and climate condition, which is known as polymorphism. The fungi shows the polymorphism known as the polymorphic fungi. And here we can begin from the first stem or black rust of wheats. The disease name is the stem rust. You can call also this name is black rust or sometimes the cereal rust. The pathogen name is the Puccinia graminis. The host plants here is wheat, barley, common barberry. So, symptoms and signs, you can see in these pictures, after the 7 or 15 days infection, symptoms on plants. And you can see in this picture under the microscope, of course, you know that we are doing all this analysis under the microscope in our laboratory classes. But unfortunately, right now we have not this condition. That's why I'll show you in our slides. So you can see under the microscope this kind of spores for rust diseases, and here is also the postulate may be abundant on the process on the both of leaf surface, including here upper and lower surface, stems or host plants. So you can see in this picture is from late of season. The late of the season postulates of black teliospore. Just take care about this point here and wheat. So the infection of plants under the microscope, teliospores are two-celled. Already the cellid is changed. You can see in here two-celled and the thick equivalent. So environmental factors and environmental condition. Actually the hot days for favorable for this pathogens between 25 or 30 degrees, and midnight is 15 to 20 degrees available temperature for pathogen. And also leaf wetness from rain or dew making available condition for pathogens. So here as you can see the life cycle of pathogen. Actually the sexual cycle on the wheat, it happened during the vegetation time from early spring to late of fall or autumn, I call. So, and you can see in here teliospores. And after the summertime, you can see teliospore, and over winter is a teliospore, early spring. You can see in here is the basospore, and basospore infect the plants, and all this life cycle is continue again. So leaf or brown star of wheat, then disease name is leaf, sometimes we call brown rustus. The pathogen name is Puccinia tritia, and host plants in here wheat, barley, and common barberries. So you can see symptoms and signs on the plants. So the critical small brown pustulators you can see in here, all these pictures. And also the pustulates color is the spores color is a red orange spore developed on the upper leaf surface, and the leaf shades, glamus, and also earnest. Black pustulates from as a plant approaches the talia, which is you can see these spores under the microscope, and here is the late stage of diseases. And teliospore are already two-celled. So what about the environmental factors? Warm, humid weather condition is an intermittent rains, and here is also hot days, which is I said to you before, like other diseases. 25 between 30 degrees is a available condition for development of diseases, and leaf wetness from rain and also dew. And again, here you can see the life of disease cycle, life and disease cycles of the Puccinia tritia on wheat plants. So the same process continue, just focus on asexual cycle of the wheat in here, Brunia on leaf. This process continue during the all vegetation time, and infected your plants, and it is possible to go from one plant to another plant during the vegetation time and infected whole fields. So you can see also in here life cycle of Puccinia tritia, and stripe or yellow rust on wheats. The disease name is strip or yellow rust. In here you can see clearly these pictures, and pathogen name is Puccinia. Hosts only wheats. For these diseases, yellow rust, only wheat plants are hosts. So, symptoms and signs. The first sign of strep rust is the appearance of yellow streak, as you see right now in here, and followed by small, bright yellow, urine pustules arranged in the concentric around the leaves, leaf shades, glands, and ornus. And again, you can see in here some spores under the microscope. Multipastulate will be break epidermis and the related yellow-orange mass of the urinary spores. So, black pastulate from as a plant, you can see in here the teliospore of strep rust, and already you can see some spores, and these pictures from late of season. You can see already the spores colors changed from yellow to a little bit dark. And per disposing the factors, environmental condition, actually humid weather condition is favorable for these diseases, and color climate, actually 10 to 16 degree is more available. And of course, late leaf wetness and from rain or dew, heavy dew or intermittent rains can accelerate the spread of the diseases. The stage of the rusts in wheat. At first, I would like to begin from the first stage. And you can see in the first stage, rusts can produce up to the 5 spores types during the life cycle. The first life cycle, the first stage is, you can see in here, haploid germination in the heterolytic rusts. And first, this is 0 and first stage. All of it is a 5 stage, and I begin from first, which is I showed you with 0, from 0 to 4. So the haploid gametes in the heterolytic rusts, and first stage we can see non-repeating dikaryotic vegetative spores, and third stage we can see the spores are referred to as the repeating the stage because they can cause auto-infection. These spores are red, sometimes orange, and are characteristic sign of the fungus or infection. So the third stage is a haploid spores already that produce basidi are the cerebral stage of the cycle, and last stage in here we can tell stem from basida haploid spores which is infected alternate host already. So the management of rust diseases of wheats, I can tell you some control or management methods, which is first one is we can use cultural practice, grow early maturing and resistant wheat varieties, approach the sprinkler fertilizer, actually nitrogen, and chemical control it. I wrote here some chemical contents. You can use this kind of chemical for management of rust diseases. And here is also destroy the common barberry and save the wheat. If there's some common barberry near your field, you have to destroy all these barberries near your fields because there are also hosts. So right now I would like to begin from smuts of wheat. This is another group. The first is loose smut of wheat, second is heel band, third is carnal band, and last one is a flag smut of wheat. I can tell you the black powder spores, teliospore, are typical of smut disease, which is also included to bands. So, loose smut of the wheat, the disease name is loose smut, and pathogen is Uslogen nuda terici, and which is in here. The hosts are wheat, barley, and commons. So, symptoms and signs. You can see in here the sign of some symptoms on wheat plants. Every year of the affected plants is covered in the black mass of spores, and grains are formed. So, in infected heads emergence from the bud once the 3 days earlier than those of the healthy plants. As a rule, all the glands, cuffs, and the grains are smutted, and completely all this head part of the plant completely transform it and in the black powder. And never we can take any yield from these plants. Already everything is done in this point. So this short mass is a composite, almost earlier than millions of teliospore. And here as you can see a lot of teliospore. This picture is under the microscope. Then the spores are quickly separated by the wind. The winds can take all the spores from one place to another place. At the same time, the spores spread everywhere and they infect the other plants in your fields, in our fields, I can tell. So, also, all of the follower parts of the head, express the rex and the principal members are involved by the mycelium of the fungi and converted in the loss against of the small spores. And all of them is, again, I would like to tell you, teliospores. So, the factors. At first, wind. As I said you, the wind is take all spores from one place to another place. Of course, in here is also moderate rains and cool temperature. The temperature is actually the favorable and optimum temperature between 16 and 22 degrees Celsius. So, and here's the disease cycle of the loose mats. And you can see already infected plants in here. And grain site is replaced by the mass of the teliospores. And the teliospore land of flowers of healthy plants and infected develop of the grain. And after that, we are using from this grain, the mycelium evades the part of the embryo in the seed. When we are seeding, when we are planting our plants, the mycelium invades the young seedlings. And the mycelium flowers growing point of the wheat plant. After that, the mycelium invades the grain sites. And again, this cycle is continue during the vegetation time. So, the management of the loose mat of the wheat, at first, we have to, I would like to begin from the first from here, disease control, and seed treatment. The seed treatment is first and important case. Use of the resistant varieties. The most successful method is the use of the resistant varieties. Which is resistant varieties is if you compare with other varieties, there are more resistant and they are infected less than other plants. And of course, here is crop rotation. The crop rotation is a suitable, in Wales is also effective disease control. So, what's the seed treatment? I would like to give a little bit more information about seed treatment, which is in here we use from hot water treatment. The seeds are first soaked in the water for 5 hours, and we have to keep 5 hours at say 20 Celsius degree. After that, the water is drained, and often they are treated, which is the water at 49 Celsius degree for about a minute, and they finally with hot water 52 degree. We have to keep approximately more or less 11 minutes. Immediately after the hot water treatment, the seeds are cooled by dipping all cold water and dried. The dormant mycelium inside of the seed, then all the mycelium, the pathogen mycelium, fungal mycelium, will be die inside of the seed. And here is also, you can use fungicide, some systemic fungicide, which is I gave you here, the several fungicide names, and we can use from this fungicide. Also, sometimes we can use 3 or sometimes 2 fungicide together for management of these diseases. And healband of wheat, I would like to give also some information about healband of wheat, which is actually the plant seeds infected by healband. The healband or stinking smut, we are calling this name like this, and also we call common bud. The pathogen is Tilletia caris and Tilletia fodita. The host plant is only wheat. So, the symptoms and signs, plants with common bond may be moderated students in the infection plants cannot be easily recognized until near maturity and even then it is a seldom conspicuous. In here you can see infected seeds, you can see how the surface of seeds changed, color, also some deformation on the seeds. So, after the initial infection, the entire kernel is converted in the source consists of the dark brown. You can see in here the dark and brown color on our wheats. So, which is a teliospores already covered by modified predator, which is then is a prepared. The source is the light dark brown and cellulose is a bound ball. So, here is also the bounded heads are slanted and the flesh green in the May stage greener, longer than healthy heads. The bound balls change the dull gray brown as a mandatory, which is they become conception. The trigger overing of the bonds are repeated the harvest. Production causes the spores. The spores have a fish odor. So, this is cycles of the hull bond, and we can see how the systemic infection of the wheat plant. Already they include the stems and veins. And in first stage, you can see how the germination of pathogens. Then after that, the mycelium invading the wheat head. And after that, intercellular hyphae become the teliospores. And you can see in here infected plant. And after the infected plant, you can see how it changes the healthy head of plant and infected plant, which is we call this this plant already. This name is bund. And after that, the bunted grain. You can see in here the seed, and again the infected seed. Inside of infected seed, the pathogen is developed, and which is they make teliospore and basospores, and the cycle continue again. So, management of the heel band of the wheat, at first the disease control, it is actually the seed-borne diseases. That's why we have to use systemic infection or such as the spray of the fungicide. It will be not effective controlling of the diseases because the diseases come from seed. And seed treatment, systemic fungicide like carbenoxin we can use. But again, I am telling you, it is not more effective. And also, we can use of resistant varieties, which is a more effective and successful method is the use of the resistant varieties. And the last one is here, I am going to show you crop rotation. The crop rotation as a suitable involves also effective disease control. So, in here we can see kernel band of wheat. This is kernel band, or sometimes called partial band. And pathogen name is Tiletka indica. The host plant is wheat. Let me briefly tell you something about history of the kernel band. The kernel band is so named because it was discovered in 1931 on wheat, grow new kernel in India by Mitra. Since then, from that time, it has been founded in all major wheat growing states of India, as well as another country in Pakistan, Iraq, Mexico, and also Afghanistan. So, the symptoms and signs of the kernel band, it is difficult to identify it in the field. That's why if you want to diagnose of the kernel band, you have to take your samples from field to bring to your laboratory for diagnosis. So, the difficult to identify in the field, that's why the development wheat kernels are randomly infected and usually only partial is converted the fungus and hence call it partial band. So, you can see in here what's the difference between infected and healthy seeds. As you know right now, the band of D, you can see how the plant, how seed surface and structures change it, and you can see some discoloration inside of seeds. Already you can see with your eyes. And the top side of the picture, you can see healthy seeds. What's the difference between them? Color, structure, and surface, also deformation. So the disease is not usually noticed until the grain is threshed partly smattered, kernels are exposed. Generally, a few florets per speaker and affected. So while the disease seeds usually treated as a partial seeds, the embryo and the part of the endosperm have been converted to masses and small black spores. You can see in here small and black spores. So which emits the fish dough. And here is another picture, symptoms and signs. The picture is under the microscope. Infected carnets and the carnets teliospores. So the teliospores are black and sometimes brown in a color. You can see in here. Ellipsoidal and shapelet in the shape, the configuration, and characteristically the apiculations, the episodes, the retulations is with curval spines. So what's the factor? And you can see the 16 or between 24 degrees Celsius is moderate temperature, and of course rain and moisture temperature, moisture with condition. And in here is life cycle of the Tilletia indica, and you can see infected plants after the advanced infection, the teliospores in here, the germination, after that the beginning of germination, you can see teliospores in the soil surface, and they can live on the soil surface, and then they can infect your plants, and you can see in here primary sporody on the leaf surface, and again the plant seeds are infected, and the disease cycle continues during the vegetation time. So here is also life cycle of the carnal bond. The picture is a little bit more clear than other pictures. That's why also I want to show you these pictures, and you can search in internet. You can find also some coloring pictures about the carnal bond. It will be more clear, and it will be, I think, more useful for you. So in here is also management of the carnal bond of weeds. The disease control is first basically seed and soil borne. At first we have to take care about our seeds and soils. So use of the resistant varieties, it is important because the most successful method is the use of the resistant varieties. In here also crop rotation. The crop rotation as a seed pool enables also effective disease control. And also we can use disease-free seeds. It is, for me, it is so important if we don't bring to our fields, if we don't bring to our field clear or free seeds, then never we can be sure it will be happen in our field or not. So also soil is important. And here is also spray, and we can use also chemicals for management of diseases. So here is also again seed treatment, include here the hot water treatment. How we can do this? At first we have to, seeds are first soaked with water for 5 hours at 20 Celsius, and the water is the dry net of, and they are treated with hot water 49 Celsius degree, which is I said to you before about this point, and we can also use from systemic fungicide. So, and we can see also in here flax moth of weeds. The disease name is flax moth, and also here is include the pathogens names, and host plants is wheat. So here is the symptoms. You can see in here how the plant leaves are curled. this name is, of course, flat spots. The flat spots causing is a spot in cereals, effective layers, and also leaf. And it is a characterized by changes of the linear. So within the plant's tissue, you can see that later you can see spores on the weeds. These tracks have a grassy appearance. The disease plants remind the students and they produce expensive the remains of the trees, raise the twisting and the affected leaves, which is dropped down like flag and finally wintered away. So here is another disease, powder mildew, the fungus Bulmeria. So the pathogen is the powder mildew is the most common disease grains worldwide. The symptoms include white powder growth on the surface, all plants parts, or older mildew may become brown or gray. When it happened late of season, already after the vegetation time, early or late of season, the spores getting to brown or dark color. So the fungus doesn't not kill the plant, but can cause standing on the extensive yield losses. At the end of the season, small round brown-black spores you can see on the surface of plants. Here is a cultural control. Avoid excessive nitrogen fertilizer and very early planting. Destroy volunteer wheat plants in your fields, and of course, winter wheat. Some resistant varieties are available, but resistant is not durable. You can use also chemical control for chemicals for control of diseases, and seed treatment. You can use also fungicide, and it is so helpful, but only in the first few weeks after germination. So I would also like to I would like to talk also about the Fusarium head blight. It is so important diseases. So the Fusarium head blight of the wheat, also called, sometimes they call this head scab. The causes mainly by the fungicide Fusarium. So the diseases particularly the causes significant yield losses and reduce grain quality, and also produce mycotoxins. This is mycotoxins so dangerous for animals, also for human. And the chemicals that are toxic, as I said, for humans and animals. The Fusarium head blight is the symptoms are confined to the wheat head. In here, I would like to show you the grain and sometimes the stem near the wheat head, like this part. The typical the first noticeable symptoms is bleaching of the some or all of the speckles, while healthy heads are still green, like here. In individual speckles infected by Fusarium, and during the favorable condition, if the condition is favorable for pathogen, temperature, moisture, and other factors, of course also wind, then the fungus may spread into the roots and infected other plants. So, as you can see in here, infected specular and ridges in this part, and also in here. You can see pink color or sometimes orange mass of spores here may be visible for infected speculars. These spore masses are produced during the wet, humid weather condition. If the weather condition is available, then spores produce and they spread during under the favorable condition. So, also as the fungus move into the ridges, speckles located above or below in here, initial infection point may also become blotched. So, you can see clearly what's happened, what's going on seeds. The infected seeds, you can see in here how the color is changed, and also healthy seed. The bloods and severely composite gneils in left side, infected seed, and right side, healthy seeds. So they commonly tombstones appear shapely, discolored, and are light-weighted. The weight is difference between healthy and infected wheats. They lose their weight, they lose their color, and they lose their oven structure. So, what about the favorable condition? I can tell you the optimum temperature for infection are between 24 Celsius degree and 29. But during the period, high humidity and moisture, infection will be occurred at a lower temperature. So, the disease management in here, you can see effective Fusarium head blight management requires the integrated approach. What does mean? You can use different management methods at the same time. It will be more effective than single management methods. So, at first you have to select resistant varieties, and commercially available wheat varieties are highly resistant to Fusarium head blight, but moderate resistant varieties are available. Also, malaria-resistant plants, I said to you, and plant high-quality seed. Planting high-quality seed can minimize seeding blight, and also before the planting, the clean seedles with symptoms of the Fusarium head blight and conduct the germination test determine seed vigor. And also, fungicide, we can use fungicides for seed treatments, can help to reduce seeding blight caused by infection seed, but they will not protect flowering wheat against infection in the spring. And also use fungicide effectively. The fungicide able to effectively spray Fusarium head blight depends on the application timing, spraying, covering, and the disease pressures. So in here you can see the stage of the wheat, stage of the plant, and I can tell you which stage of plants and which time the plants susceptible for which kind of diseases. At first, I would like to begin from here, and you can see powder mildew. The powder mildew actually infect the plants during the 4, 5, or 6 stages of plants. And here is also septoria. The septoria actually infect the plant stage 7, stage 8, and stage 9. And of course, here is rustus. All rustus actually infect the plants during the stage 10. And finally, I would like to tell about the Fusarium head blight. Actually, the Fusarium head blight infect the plants late off and stage 10.5 and flowering time of the plants. So you can take this information. Of course, I will send you this presentation, and it will be more useful information for you, and you will know which time is plants more susceptible for which kind of diseases. So here is also, I would like to give additional information about wheat diseases. Here is also wheat seed gall nematode. As I said you before, during our laboratory time, in future, we will do all this analysis with our hands, and you will see alive symptom, also alive nematodes in plants. So the pathogen is a nematode, forms gall, the infected flower, seeds, head of wheat, barley, and related wheat grasses. The juvenile is a juvenile is a, how I can tell this, the part of the pathogen's life, which is during this time, the juvenile live inside of the plants. The moist condition are moved to other plants. They are moving from one plant to another plant, and they are splashing with rain and irrigation. So the cultural control is a clean seed before the planting to remove the galls, and also rotate the crops other than grains for 1 year. You have to do crop rotation minimum 1 year in your field. There are not any chemical control for the nematodes because they are living inside of the seeds, also in soil. It's a little bit difficult to control them with chemicals. So here is also wheat streak mosaic virus. The mosaic virus of the wheats, so dangerous because they spread on the wheats with vectors. The wheat streak mosaic virus spread by the actually leaf curl mites. You can see in here the leaf curl mites, which is there are vectors for viruses. So, and you can see in here wheat spindle streak virus. There are spread by the soil-borne fungi. Actually, the soil-borne fungi take those viruses from one place to another place, and they are spreading by soil-borne fungi. So, how we can manage them? We have to use resistant varieties, and also damage is usually not severe, especially when temperatures stay above the 65 Faraday. You can convert the 65 Faraday from Faraday to Celsius. So here is a control of the wheat curl mite. At first you have to control the vectors. After that breaks the green breach. Then they destroy volunteer weeds. If you have the volunteer weeds in your fields, you have to destroy all of them, and you can minimize the infected. And also burn down any grasses 2 weeks before then planting weeds. So at the end of the slide, here is the last slide. I would like to tell you something about the coronavirus. Dear student, dear listener, stay at home, please. Try to help the government and wash your hands during the day several times. And also reach out to your friends by phone, text, or online. If you know someone which is a doctor or nurse around you, please tell to them appreciate their hard work. And also use this time contact with your people online, even your friends. Thank you very much for your attention.
Was going to say usage of fungicides for treatment, not for measure.
Sorry? Which is the diseases most dangerous for plants? Okay. Second one. Okay. So, thank you very much for your question. The question is a little bit unclear for me. The treatments and fungicide control. Both of them is for minimize of disease spread, and you can use both of them. And maybe I can ask to her, or I don't know who wrote this question. So the treatments and also control and management. All of them is minimize the spread of the diseases. So you can write me via WhatsApp. I can inform you about the control of the diseases. It's not problem. So I saw also another questions.
How Emrin Nadir right
Can I read, please? Which of the diseases is the most dangerous for plants? Emir Nagiyev. Thank you, Emir. First of all, I would like to say to you, wait a minute. As I said, the first is rastas. Actually, in our country, as you know, we have a plant clinic in Department of Plant Protection in our department, in our faculty. Actually, we are receiving a lot of diseases in weeds, the rust diseases. Only 1 and 2 times I saw powder mildew and smuts on weeds. But I can tell you actually rusts on weeds. So, and next question.
Which methods mainly useful for identify these nematodes?
Nematodes, okay. Thank you very much. As I said already, but again, I would like to come to this stage. Here. Who asked this question, please? Elbey. Elbey, thank you very much for your question. At first, I would like to tell you, the nematodes actually live in soil and inside of seeds. If you want to control the nematodes, at first you have to use free seeds, without infected seeds. If your seeds already infected, already you see infected plants in your field, how you can destroy, how you can solve this problem? You have to use crop rotation and several years, because if the nematodes don't find any plants for eating, then they will live, or maybe they will die. We have also another method, the fumigation methods, which is the fumigation methods is so expensive. And you can't do this in big fields, because it is so expensive, it's so hard, and it is so difficult. That's why the first method is cultural methods. You can use the crop rotation, and you have to use free seeds.
Okay, that's all. Thank you.
Thank you.